Hi everyone. This will be the first lecture on number theory. I will be starting now. One thing, for some reason the meeting seems to say that it's for 1 hour, but the lecture should go for about 2 hours. Is that fine? I think that will be changed or something. Okay, so hi. This is the first lecture on number theory as part of the CodeChef learning program on ZIO. I hope you all went through the content I had shared on the Discord server about modular classes, but I'll still go through it even if you haven't. Okay, so can I start? Can you just give the thumbs up emoji if it's fine if I start? Uh, yes, the meeting on YouTube should have started. I think that it is streaming on YouTube. Uh, can you just give thumbs up emojis if it's fine? Alright, so I'll be starting now. Okay, great. So this is basically the plan of what we want to cover today. I'll be going over the fundamental theorem of arithmetic, basic notation on modular arithmetic, and Lcm Gcd. After this, we'll cover Bezout's theorem and Euclid's division algorithm. Then I'll just explain to you briefly what base systems are, and then we'll go over three results that were given in your first NT exam as well. Then I'll go over three of the questions from the first test, and then I have given you some problems to try later. Is this fine? Okay, great. Okay, so uh, yeah, I think someone will explain it to you what's going on. Okay, so the fundamental theorem of arithmetic, as most of you will know, is that every integer, every positive number or natural number except one, can be represented in a unique way apart from rearrangements as a product of one or more primes. So what that's basically saying is like 6 can be uniquely written as a multiple of primes, 2 into 3. You can rearrange it to write 3 into 2, but that's basically the same thing. Similarly, any number like 10, you say 12 is equal to 2 into 2 into 3. But that's basically saying the same thing, right? If I write it as 3 into 2 into 3 into 2 or anything. So that's basically what the fundamental theorem of arithmetic is. And it's also called the unique factorization theorem. You must have learned it in your classes earlier as well. So that is what the fundamental theorem of arithmetic is. Everyone is fine with it? Just give me a thumbs up if it's fine. Nice. Okay, great. So, okay, this is the notation we want to cover as part of modular arithmetic. So, A divides B means can be written in this way, or as is written here. So, this is saying that A divides B. So, 2 divides 4, 3 divides 6, and there's 9, and so on. Similarly, A does not divide B is written this way. We use the notation of congruence. So A congruent to B mod n means n divides A minus B. Okay, this is read as A is congruent to B mod n. Great, awesome. So here are note few basic properties of modular arithmetic. A congruent to B mod n means that B is congruent to A mod n. You see why this is true? Similarly, A congruent to B mod n and C congruent to D mod n, it also means that A plus C is congruent to B plus D mod n. Every number is congruent to itself mod n. Yes, the notes are already on the Discord server. I have already put them under notes and resources. You can use them side by side as well. If A is congruent to B mod n and C is congruent to D mod n, as was here, then AC is congruent to BD mod n. AK is congruent to BK mod n. And n comma k is equal to 1 means that A congruent to B mod n. Do you know what n comma k equal 1 means? What this, what I mean by this? Yeah, yes. So I'm basically saying that n and k are co-prime. So if n and k are co-prime, then I can remove k from here and I'll still get two congruent numbers. I have already shared the link on the Discord, but you can use this to get a more detailed introduction. If these properties are fine, give me a thumbs up, please. Uh, the Discord server for the ZIO course is, I think, available to all those who have enrolled for this course. They'll share it with you. Okay, so point 2 says A congruent to B mod n. So this is saying that n divides A minus B and n divides C minus D. Then n divides A minus B plus C minus D. So you can obviously you can now show this directly. Right, n you can write a minus b is equal to n into x, where x is some integer. Similarly, c minus d equal n into y for some integer, because c minus d divides. So yeah, okay, great. You got it? Is everyone now fine with all these properties? If any property is troublesome, do tell me. Just give me thumbs up. Or if it's confusing, you can also give a confused emoji. Okay, great. I think everyone got it. Oh, second last line. Okay, so this is saying, for example, I'll take an example. So if AK is congruent to BK mod n, that's saying like if 5 into 12, which is 60, is congruent to 5 into 6, which is 30, mod 10, right? Because 60 is congruent to 30 mod 10. You can see that because 10 divides 30. So I can remove 5 from both sides here. Sorry, what am I even saying? Ignore me, please. Let's take this as 2. 60 is congruent to 30 mod 2, right? This is true. Now, because 2 and 5 share no divisibility, I can remove 2 and 5. So, like, I can write this as 5 into 12 is congruent to 5 into 6 mod 2, right? This much is fine, right? Okay, so now 5 and 2 are co-prime, so I can remove 5 from here. So AK into BK is congruent to NK, so this becomes 12 is congruent to 6 mod 2. Now similarly 3 is also co-prime to 2. So I can again remove that, and now I can say 4 is congruent to 2 mod 2. But because 2 and 2 are not co-prime, I can't directly say 2 and 2 is congruent to 1 mod 2, which is obviously false. This is not true. But when they were co-prime, I could do this. I could just remove them. Is that fine? Okay. So the crux of this notation is now instead of always okay. So for example, okay, I see some people are still confused. Could you explain what the confusion is? They're not congruent directly. You can never say that two numbers are congruent themselves if they're different. Congruence is always modulo some number because you are basically saying that as we said in the previous slide, see what congruence means. So if you can say 60 is congruent to 30, but if I you can say that, but okay, that's not preferred, right? Because you don't want it to become clunky. Now in this way I can write 10 things. I can write 2 congruent to 4, congruent to 6, congruent to 8, mod 2. Or I can say 1 congruent to 3, congruent to 5, congruent to 7, mod 2. So this becomes easier, right? Because now we have a clear message. But if you were using mod 2 everywhere, it would become very clunky to say. It's fine, you can say that, but it isn't very helpful. Uh, I don't get what you mean, factor of each number. No, I mean like if you take 7, I can say 10 congruent to 3 mod 7, right? Because 7 divides 10 minus 3. I can say this is congruent to 17. So this is, I guess that most of you didn't know the notation. So this is a very commonly used notation which you'll encounter everywhere eventually. It's written this way only. Okay, so now can you give me a thumbs up if everyone got these two pages? If there's still some issue, you can say. Alright, I think everyone got it. I'll move on. Okay, so can you try problem 1? I'll create a poll, right? Uh, you can try problem 1 now, please. Oh, okay, okay. Okay, so the correct answer is actually C. This is true, this is also true, and this is also true. Because observe, 5, as we discussed, is co-prime to 73. So I can drop it by the last rule, right? In the second problem, we have 3n divides 93 minus 27. So now you can see this is saying 3n into x equal 93 into 27. 93 minus 27. Now I can, because I can remove, because of if I divide both sides by 3, I can say this is equal to this 9 into x equal 31 into 9. Option A, last rule we discussed, right? If AK is congruent to BK mod n and n comma A k is equal to 1, this means A is congruent to B mod n. So 5A is congruent to 5B mod 73 and 5 and 73 are co-prime. So A is congruent to B mod 73. So okay, back to this. Second, I say n into x equal 31 minus 9. So this means that n divides 31 minus 9, which is same as saying this, right? And here I am basically saying 27 minus 11 is equal to 16, and 4 divides 16, which is, we know is true. So this is also true. But we can't say this, right? Because 5 and 1005 are not co-prime. Do you understand? So we can't directly do this. As we observed that we need 5 and 1005 to be co-prime if we are going to remove the 5 from here. If it's fine, could you just give me a thumbs up again? If you still don't get it, you can say. I'll. Okay. I think everyone at least has a fair understanding. Okay. Now you will try problem 2. I will create a one for that. Okay, please try. Okay. Okay, there's still some things. Okay. Some of you still don't understand. I'll try to explain. Okay, so first problem. We know that 4 is congruent to 4 mod any n, right? Because n divides any n divides all numbers divide 0. So by this rule, if A is congruent to B mod n and C is congruent to D mod n, we have A plus C is congruent to B plus D mod n. So I can add 4 to both sides. So 15 is congruent to 9 mod n. Here I can't remove the 3k because I can't directly remove. Okay, for example, if I was saying 3k is equal to 66 or k is equal to 22. See, 9 is not congruent to 31 mod 66. But 27 is congruent to 93 mod 66. So I can't say this. So this is false. Now if 51 is congruent to 5k mod n, then 306 is congruent to 30k mod n. Right? Because we can multiply. Now I can subtract 6 from both sides. So I'll get that 300 is congruent to 30k minus 6. Mod n. Similarly, for the last thing, I can say 4 is congruent to n. So 12 is congruent to 3n. So 13 is congruent to 3n plus 1. So this is also true. So the wrong option is B. So now does everyone get what we did? Okay, so there's still some confusion. Could you tell me what the issue is? Because I don't want to move on further from this if everyone is not comfortable, because this is a very crucial part that will be used in all of NT. Could you just type what the issue is? Someone reacted that they're confused. Uh, okay. I, the notation, you have to familiarize yourself with this. This is not just for my lectures. Everywhere you go for number theory, anywhere you learn. And number theory will be crucial for your future computing Olympiad prospects as well. You should be familiar with congruence notation. So I don't want to avoid this. Even if you're uncomfortable, you should familiarize yourself with this notation. I'll give you 2 minutes to just read the properties and get comfortable. React with a thumbs up when once you're fine with it. Because I don't think I can explain it anymore or in a better way. Alright, if it's alright, okay, great, I'll move on now. So the next concept is we have LCM and GCD. Now, I assume that you all know what LCM and GCD is, but I'll still tell you once for the sake of completion. So, completeness. So this LCM of some numbers a1, a2, ak is the smallest number such that ai divides l. Natural. L is obviously also natural because we are working with division there only right now. Okay. So similarly, GCD or the HCF is the biggest number that divides all the given numbers. That is A1, A2, A3 and till AK. So that is defined as the GCD. You may have also called it HCF, but GCD is a more commonly used term. So I think it's better if you use GCD. Okay, is that fine with everyone? These definitions? Or it just give a few thumbs up. All right, great. Okay, so now we have a few properties of GCD and LCMs. So if our first number is a, which has which can be written by the fundamental theorem of arithmetic as a multiple of some prime. So if it's some prime p1 to the a1, p2 to the a2, till pk to the ak, and it's the other number is b, which is p to the p1, p2 to the p2, till pk to the bk. Now where bk are distinct primes and ai and bi are non-negative integers, then I can write the LCM as P1 to the maximum of A1 and B1, because any lower number, if I put in A1 or B1, it won't be divisible. But if I put a larger number, this would be less than that. So it would it would not agree with that definition. So it's written as maximum of A1 B1, P2 to the maximum of A2 B2, till Pk to the maximum of AK Bk. Similarly, the GCD is defined as P1 to the minimum of A1 B1, P2 to the minimum of A2 B2, till Pk to the minimum of AK Bk. I think these results you must have seen in earlier classes as well, where they didn't necessarily give you it with proper notation, but you must have been asked to calculate the GCD and HCF via this technique, where you prime factorize them and then just compare the powers. Okay, now if D divides A and D divides B, then D must divide the GCD. Similarly, if A and B both divide some number D, then LCM must also divide it. And then we have LCM into GCD is equal to A and B. We can prove this by using this. Because you know the max plus min, max AB plus min AB, I won't be showing any codes to you because, well, I'm not from a coding background anyway. A comma B is equal to A plus B. So I apply this on every power because see, the power of L into G for P1 is minimum A1 B1 plus minimum of maximum of A1 B1. Here it's A1 plus B1. So every power will match up. So I'll get this result. See, obviously, this result and this result is also true for greater than two numbers. So if it's there was a third number with P1 to the C1, here I would just add a C1. Here also I'll just add a C1 and so on. Then we have these two properties, which you can observe from which you should know from as you have done previously from the modular notation. You can show these properties as well. So GCD of B plus A is GCD of A plus B, which is GCD of A minus B and B. So I can subtract if one term from the other and keep any term. So here also I subtracted one term. See, I subtracted this from this to get this. And lastly, we have GCD of AB and C is less than GCD of A comma C into GCD of B comma C. You can use this result for that. And here also we have this. So these are some basic properties of GCD and LCM that you should know. Are these fine with everyone? Give me thumbs up if it's fine, and give me a confused emoji if there are some issues. Okay, I think you did not get the first one. Okay. Hmm. Okay, what's the issue? Could you explain? Yeah, these are nice properties. Okay, here. Okay, so the thing is, for you want primes to divide a number, right? Because every number can be written in a way as a decomposition of primes. So I can add, so whatever the decomposition of L would be, its factorization, it will have P1 to some power, right? Now if I consider what power of P1 I can give it, if there is a power I want to give it, it can't be less than any of these because then these numbers won't divide L. But if it's larger than the maximum, then that's unnecessarily high because we want the lowest common divisor, not a larger number. So if I set it at max a1 b1 and similarly all powers are set as maximums, I'll have that a and b divide them and I'll have found the lowest number that I could. Similarly, I want the maximum number here. If I take a larger power than minimum, then the number won't be divisible by the GCD, which is an issue. And if I take a number power lower than the minimum, then that's unnecessarily low. We are trying to find the greatest common divisor, not the lowest. So I hope that's fine with you. I hope you got it. Is it fine? Just give thumbs up if it's fine. Alright, so I'll give you 2 minutes to digest these properties and then I'll move on. Okay, I can do that. See, for any number b, if it divides a, it divides b. And if this is true, then we know that d must divide a plus b as well. We have seen that already. The GCD of a comma b will divide the GCD of a comma b plus a, right? The GCD this number divides this number. But if d divides a and d divides b, then d divides a minus b as well. So this GCD will divide this number. So if a divides b, a divides b and b divides a, then a equal b. You understand what I did? D divides A and D divides B, then D divides A plus B. So the GCD will divide this value, and D divides A and D divides A plus B, then it divides B as well. So we get the other way as well. So both must be equal. Yes, it would divide the LCM, yes. Uh, GCD AB comma C is less than equal to GCD A comma C and GCD B comma C. So if I say A has power P1 to the alpha 1, I'll show this for just one prime and then you can extend it yourself. And B is P to the alpha 2, P1 to the alpha 2, and C is P1 to the alpha 3. Now you want to show that the minimum of alpha 1 plus alpha 2 and alpha 3 is less than equal to the minimum of alpha 1 alpha 3 plus minimum of alpha 1 alpha 4. Sorry, alpha 1 alpha 3 and alpha 2 alpha 3. This is obviously true. I think you should be able to see that the minimum of alpha 1 plus alpha 2 and alpha 3 is less than the minimum of alpha 1 alpha 3 plus minimum of alpha 2 alpha 3. So that's what this property is, and the other property is the symmetric case, saying maximum of A plus B comma C is less than maximum of A comma C and plus maximum of B comma C. Okay, so this is saying maximum of alpha 1 plus alpha 2 comma alpha 3 is less than equal to maximum of alpha 1 alpha 3 plus maximum of alpha 2 alpha 3, which I think should be intuitively true. If it's fine, could you just say it's fine? Uh, do people still have issues with this? Okay. Uh, what did you not get? This lecture. Oh, can you alphabet? Do you understand what I'm saying? At least, even if you can't exactly read it, I think you should be able to understand the crux of what I'm saying. Okay, I'll review it with you later, or someone will get you in the chat. I think I can't really stay on this for much longer. Yeah, that is true. If D divides A and D divides B, then D divides the GC. D divides the LCM. That's totally true. Nothing wrong with that. Uh, yeah, I'll be going a fair. I'll not be going very advanced in this lecture. But by the third lecture, I think you may find some interesting stuff. The basics of what I'll be going through in this lecture are given initially, so I think you can just check the PDF. Okay. Could you try this problem now? I'll give you 15 more seconds. I think a lot of you are not attempting. Please attempt at least. It will give me an idea of what you're thinking at least. We won't be discussing the golden ratio very much. I don't think it's really important here. Yeah. Okay, so the correct answer is actually A. A is not true. You can actually check this by letting 3 equal A and 1 equal B, because GCD 2 comma 4 equal to 2, but GCD 1 comma 3 equal 1, so they're not equal. So they're not equal, so this is false. This is just our last, this is a property we just discussed. This is the same thing. So this is true. We have seen this as well here. So this is also true. D, okay. We'll do that trick again. So 55A plus 34B, comma 34A plus 21B can be written like this. Now I can switch this to 21A plus 13B and 34A plus 21. Now I can go again. I'll get 8A plus 5B and 21 comma plus 13. Sorry, I'll get 13 plus 8. My bad. Then I can go down again. I'll get 8 plus 5 and 13 plus 8, and I'll keep going down and down, and I'll eventually get to A comma B. You can repeat the process by hand. It's difficult for me to write here, but I think you get the crux of what I'm saying. If it's fine, just give a thumbs up. This is unnecessary right now, but I'll the property should Vivek, but it's you can DM it to me and I'll explain it to you later. It's not relevant right now. Okay, so 55A plus 34B is basically saying 34A plus 21A plus 21B plus 13B. Right? Now you can subtract 34A plus 21B. So I'm left with 21A plus 13B. Now I'll subtract this from this. So I'll get 13A plus 8B. And I can keep repeating the process. Now I'll subtract this. I'll get 8A plus 5B. Then I'll subtract again. I'll get 5A plus 3B. I'll subtract again 3A plus 2B. 2A plus B. And so on. And I'll eventually get just A comma B. This process can keep repeating. Alright. If it's fine, just give a thumbs up, and if there's still confusion, do tell me. I can see that there are 14 people, but only 4 people have reacted. Okay. I'll move on assuming that you got it. Okay, great. So now we come to the Euclidean division algorithm. Now, I believe that you have seen this before, but I'll explain it to you. We can write any number a in the form of bq plus r, where b is some given number, and we can find q and r such that this is true and r is between 0 and a. If you're not familiar with the notation, this just means n, and n is the set of natural numbers. So a and b are natural numbers. That's all this is saying. Similarly, q and r are in the set of natural numbers. So we can write this way. We can write that a is equal to bq plus r. Yeah, Euclidean division lemma, same thing. So also GCD a comma b is equal to GCD b comma r. So now if I repeat this process, like from a comma b, I got to a lower number, right? Like b comma r. So now if I repeat this process, I can always keep going to smaller and smaller numbers. Eventually, I'll have to run out of numbers because there's a limit. You can't go smaller than 0. So eventually, you'll get smaller and smaller till GCD a comma b is equal to GCD d comma 0, which is obviously d because d divides this number and d divides 0. So you'll get this, which is what we did in the previous problem. We applied the Euclidean division algorithm only, but every time we were just getting q equal 1. But this is actually true for whatever q is there. Okay, nice. It seems like everyone got it. There are 17 thumbs up and 14 people in the session, so that's quite interesting. Alright, I'll move on. Okay, so this is called Bézout's theorem. Bézout's theorem is actually quite interesting and nice, so I'll be spending some time on it, and we'll actually be going over the proof of it. Let me open a slide. So, Bézout's theorem says that if you are given a and b, two numbers, then you can find x and y such that ax minus by is equal to GCD of a comma b. Do you understand why we would need at least GCD a comma b? Why we can't get a number like 1 or something smaller than GCD a comma b? Like why can't we get this set? Yes. So what? Observe that GCD a comma b divides by because it divides b. And GCD a comma b also divides ax. So GCD a comma b divides ax minus by. If a number divides a number, like if GCD a comma b divides a number, the number can't be smaller than it now. So the number which we'll get has to be at least GCD a comma b, or it will be 0 or less than 0. But if it's a positive, it has to be at least GCD a comma b, because GCD a comma b can't divide a number smaller than it. Okay, so now, okay, As I think a lot of people didn't get what I'm saying. Okay, okay, so see, the GCD divides A and GCD divides B. So GCD divides AX minus BY. So if you have a number smaller than the GCD in this set, then it can't be divisible by D, right? Because you can't divide a number smaller than yourself. I think you know that. Okay. So now we'll try to prove why this is true. Okay. So for that, I'll do one thing. I'll remove the GCD and just make it 1. How will I do that? See, the GCD divides A. So I can revise. That implies that A is equal to D into K for some K. I'll write it, say A dash. So D into A dash. I can write it this way because D divides. The GCD must divide the number and D divides B. So uh, D is equal to D into B dash. So remove the D from both sides. Now I'm trying to prove that there exists X and Y such that A prime X minus B prime Y is equal to 1. Now observe that A prime and B prime must have GCD 1 because if some number is divisible, some number divides both of them, then it will also divide A and B, which will mean that we'll have found a bigger GCD than the GCD, which is impossible. So we want to prove this. Now we'll use the congruence idea which we already had. See, this is basically saying that there exists X, this is the symbol of exists, X such that A prime X minus 1 equal B prime Y, which is basically saying that there exists X such that A prime X is congruent to 1 mod B prime. We just want to find X such that this is true now, right? Okay, so what if I now see what values X can take? X can take a value of 1, 2, 3, till B prime minus 1. And I set all these values and I say, let's check what value comes out here. Now, see that A prime K cannot be congruent to A prime L mod B prime if K and L are both less than uh, B prime, because I can just cut it from our original root. So that would mean B prime divides K minus L, and K minus L is smaller than B prime, so that is not possible. So no two of these values will give us same congruence mod B prime. So all of these will give us different congruences. But the congruence can take value from 1, 2 till B prime minus 1, and no two are same. So every number must correspond to some congruence. So some number will correspond to 1 as well. So we will get a number such that A prime X is congruent to 1 mod B prime. Is that fine? Is that fine? You can give a thumbs up if it's fine. The proof is formally written here. That we'll just consider A and B such that they are GCD 1. Now we want to find x and y such that ax minus by equal 1. So consider the set A, mod B, A, 2A, 3A till BA. That if any of these are congruent, then we'll have that AI is congruent to AJ mod B. But as A is congruent to, sorry, we cannot have this because otherwise I can remove A and that would mean I is congruent to J mod B. But all numbers are smaller than, like the difference is smaller than B. But now as the size of the set A is equal to B and there be possible congruences mod B, each value in A must correspond to its unique term in 1 to B. So we can find a unique X congruent to B in this set 1 or 1 to B minus 1 such that AX is congruent to 1 mod B because AB congruent to C. Mod B is only so we don't really have the case where the number B is also there because AB is congruent to 0 mod B. So we have found AX minus 1 equal BY and Y is obviously less than A, otherwise this won't be true. So we get, I hope the proof is clear. Give me a thumbs up if it's clear. Or a confused emoji if I confused you and it was fine earlier. It feels like a few of you stay confused with the proof. But okay, I hope that you understand at least the theorem, right? Do you understand the theorem? Even if you don't understand the proof right now. Give me a thumbs up if you understand what the theorem is saying. Okay, so a lot of you don't even understand the theorem. Alright, you should have told me. Okay, so, okay, so uh, so the theorem is saying that you can find, okay, what do you not even, I don't really understand what you don't understand. Because you can find it's all that it is saying is that you can find D such that AX minus by BY is D. So like what A, yeah, A 2A 3A BA is a set. Yes. Oh, as I told you earlier, this is the symbol for there exists or just exists. Symbol for exists. Okay. All right. Okay. Sorry. Okay, now I'll move on. Uh, Try this problem, please. I'll create the code. we can x and y can be any natural numbers. Okay, so see, the thing is, we just discussed this. That's what Bizot's theorem was, right? That you can find x and y such that x minus by is the GCD, and the GCD is the smallest natural number that you can find. That's what Bizot's theorem was saying. So our answer will be the GCD of 213 and 187, which is in fact just one. The answer is A. Yeah, we can find x. What is the minimum value that can be found if we take any x and y? That's what it's asking, right? The smallest natural number that you can find. So if you vary x and y, we don't care what the actual value of x and y is. I'm asking you, can you find x and y at whatever x and y you use? What is the minimum value you can find? And we proved by Bizot's theorem that you can find x and y such that this value is the GCD, and the GCD is the lowest value you can find. Uh, Euclidean division theorem algorithm is a how to find another value for this. What do you if you vary x and y, you'll get different values. I'm asking you what is the smallest value you can find. There you go. Someone found x and y for you, but that was not very relevant, I think. The question is just asking you what is the minimum value that you can find. Uh, yeah, so someone found you the values, but the values are not actually relevant here. We're not even asking the values. We're just saying as x and y vary, what is the minimum? So that we have shown to be the GCD, which is 1. Okay, so in this, this may be a distraction, but I'll still go through it. The idea in maths is not always to find the actual value that satisfies something, but a lot of times you want to prove that something exists. So that's what we were trying to do before. Once you know something exists, then you can try to find ways to find it. But unless you know that something will exist, it's useless to find ways, right? So a lot of the times we are just trying to show that something exists. There are algorithms. I mean, you can just find this by Euclidean division algorithm, but I don't want to go into that. That's unnecessary here. Actually, you will actually find this type of question in the NCRT of 10th class. Okay. Now I'll explain you what base systems are. Base systems, I'll not be going into depth or anything, but I just want you to know what they are because a lot of ZIO problems and other problems will ask you to convert to base X or some base, and you need to know what that means at least. Because, yeah. So, when you say a number is 3,578, you're basically saying it is. Oh, okay. Yeah, sure, sure. Take a break. Take 2 minutes to yourself. Yes. I'm sorry. I didn't consider it. as I said before, this session is 2 hour long. The number theory sessions will all be from 1.5 to 2 hours. I think the same goes for the ad hoc advanced sessions. I'll be taking those as well. Okay, is everyone ready? And then you can start again. Just give a thumbs up if you're ready. All right. So when you say a number is, for example, here 3578, you're basically saying the number is 3 into 1000 plus 5 into 100 plus 7 into 10 plus 8 into 1. But this is why it's called a base 10 system or a decimal system. See, decimal system. Because we are using base 10. But you can also use any other base. You can use base 9. So if you say 3578 in base 9, that's saying 3 into 9 cube plus 5 into 9 square plus 7 into 9 to the 1 plus 8 into 0. 8 into 1, sorry, my bad. And this way, we refer to as 3578b when we are writing it in base b. So you write the base here. So because we default to base 10, that's why we don't mention the number. Otherwise, you can write it as 3578 in base 10. Or whatever base you're working with, you can replace it with 3578. Similarly, okay. So I'll ask this question, what's 10 in base 12? Can you just type on the chat? Yeah, exactly, because 1 into 0. Okay, so, uh, no, what does 10 in base 10 mean, 12 mean in decimal system? So see, this is equal to 0 into 12 to the 0 plus 1 into 12 to the 1, which is 12 usually, right? 10 in base 12 is equal to 12 in base 10. Okay, great. So that's what base system basically means. So digits in base 10, for example, refer to 0 to 1 to 9. And in base 2, the digits are just 0 and 1. Base 2 is what we call binary. Right? Binary is base 2. Similarly, there are exactly B digits in a base B representation. Because like see, 10 digits 0, 1, 2, 3, 4 till 9. In base 2 there is 0 to 1 and so on. For more information, you can check out the Brilliant link. I've posted the whole PDF on the Discord server, so you can check it there. Is this fine? Uh, do you get what a basis, what different base systems are? Just react with thumbs up if you understand. Oh, of course not. But like, okay, if you're saying 5 in base 7, that's basically 5 in base 10, right? Because it's saying 5 into the 0 and 5 into 7 to the 0, which are both equal to the same thing. But you can't do that for larger numbers if the number is bigger than the base. Because, like, yeah. Anna, what do you want me to repeat? Adjust, sorry. Adjust. Okay. So remember in school we used to study in lower grades, write the expanded form of a number, where we had to write it like this. So for example, 512 would be 5 into 100 plus 1 into 10. Similarly, because this is 10 square, so this was base 10. I can use any base system I want. Okay, you want me to explain 10 base 12. Okay, so what 10 base 12? What does 10 base 12 mean? See, the leading digit is 0. So that's saying 0 into 12 to the 0. No, no, no. See, the digit here is 0, right? So 0 into 12 to the 0. Then the second digit is 1. So we write that as 1 into 12 to the 1. So if I sum both of these, if I sum this and this, I will just get 12, right? Because this is 0 and this is 12. So the sum is 12. So 10 in base 12 is 12 in base 10, right? Is this better? Uh, is this better for everyone? All right. Okay. I've spent. Yes, exactly. Yes, Arjun. Okay. So now we move on to some results that we used in your first test. I'll go through them with you. So the first result that you used was the number of factors. How many factors does a number have? If a number is p1 to the alpha 1, p2 to the alpha 2, then pk to the alpha k, then we say that the sigma of n or sigma naught of n usually is equal to is the number of factors that alpha 1, which is basically alpha 1 plus 1, alpha 2 plus 1, and this is the product of these. This is the number of factors a number has. How do we prove this? See, that any factor of n must be in this form only. Because if some other prime appears here, then it won't be a factor, right? So every factor must be in this form, and every power must be less than or equal to the corresponding power. So bi is less than or equal to alpha I, and it can be 0. So bi can take values like alpha I plus 1 values, that is 0, 1, 2. 10 base 10 equal x base 12. Oh, okay. So, oh, I see what you mean. Okay, so usually I'm sorry to diverge, but when we move on from base 10 to 12, we replace the digit 10 with the digit A, and we replace the digit 11 with the digit B, because otherwise it would be very confusing what they mean. So, yeah, so 10 base 10 is equal to A base 12. Sorry for the confusion. Okay. So beta I can take the values from 0, 1, 2 till alpha I. These are alpha I plus 1 values. So P1 can take the power of P1 can be one of any of these values. Similarly, you can find similar numbers for everyone. So you get this sigma is just the product of these values. Fine. Is this okay? All right. Okay, great. Now we have another result, which is the number of numbers less than a number which are co-prime to it. That's given by phi of n, right? So when the number n is p1 to the alpha 1, p2 to the alpha 2, repeated to the alpha k, where alpha is greater than 1, then alpha n is given this way. It can also be written as yn into 1 minus 1 by p1 into 1 minus 1 by p2 and 1 minus 1 by pk. This is the same thing as this. So if A, now we'll try to prove by this string. If say A is a number that is co-prime to n, then mod pi, it can take pi minus 1 values. So if the value of A, so the value of A can take pi minus 1 into p to the alpha I minus 1 values mod pi alpha I. So mod all of these numbers, it can take the product of these values. P1 into alpha I minus 1 to p1. This value, this value. You can just choose the congruence for each and you'll get a number. Okay? Is that fine? Okay, great. And lastly, we have this theorem, the sum of divisors. The sum of divisors is given by sigma 1 of them. And when n is this number, sigma 1 of n can be represented this way. So now, see, if the set of divisors of mn can be written as m prime, where m prime divides n and n prime divides n, right? So the set of divisors can be represented this way. So the sum of all these divisors can be represented as a sum of divisors of, okay, sorry, my bad. Here it should be a D, here it should be a D, here it should be a D. Sum of all divisors of Mn is equal to sum of all divisors of M into sum of all divisors of N. So we can write sum of all divisors of N is sum of all divisors of P1 to the alpha 1 into sum of all divisors of P2 to the alpha 2 till sum of all divisors of Pk to the alpha k. So the sum of all divisors of P1 to the alpha 1 is just this. Sum of all divisors of alpha P2 to the alpha 2 is just this. And this is this. Now we know by geometric sum, this value is equal to this value is equal to this value, and this value is equal to this value. So that's our sum of divisors. Okay, is that fine for everyone? Uh, you can react with a thumbs up if it's fine. Alright, great. So this was the problem that you were given in this set. Yes. So now try to find these values. A lot if you didn't solve this, I think. So you can try it now. Okay. So can you tell me the answers? How will we find them? Okay, I'll explain it to you for one of these. Then the others you can try on your own. See, the 29700 is 1000 into 297, which is 2 cube into 5 cube into 27 into 11. So that's 3 cube into 11. 3 cube into 11. So what's our sum of number of factors? 3 plus 1, which is 4, into 3 plus 1, which is again 4, again 3 plus 1 into 4, and 1 plus 1, so into 2. So it's 128. Yeah, exactly. Number of numbers co-prime to this. So what's our formula? N into 1 minus 1 by 2 into 1 minus 1 by 3 into 4 by 5 into 10 by 11. So we get 1 by 2 into 2 by 3 into 4 by 5 into 10 by 11. So this I can cut. I'll get 2, and this I can cut. I'll get n into 8 by 33, which upon calculation is just 72,000. This you can try on your own now. Okay, fine for everyone? So these were three of the problems, two of the problems that you were given in the set. Now, you can try on your own again because of congruences. You have done that. So this is for you to try. I'll discuss this. So see, every rational number can be written in the form p by q. Yeah, yeah, that's correct. Yeah, we have discussed it before as well. So the rational number that you'll get is p by q because every rational number can be written in this form. And because p by q is less than 1, that's why p is less than q. We also have p comma q is equal to 1 because we are taking lowest form, right? Lowest term. Now we have that p plus q equal n. And this is true and this is true. So see, if p comma q equal n equal 1, implies p plus q comma q equal 1. But p plus q is just n. So we have n comma q equal 1. So q can be any number co-prime to n. How many such numbers are there? We have said that is phi of n, right? But see, q is also larger than p. So it cannot take half of these values. It cannot take like the smaller value, right? If there are if it's q, then it can't be n minus q as well. So it has to be like one of these values. So our answer is phi of n over 2. Phi of 10 is 4. So half of that is answer 2. Phi of 87 is 56. Half of that is 28. 17,017, you can find that how? 17 into 7 into 11 into 30. So now if you find 5, that's 16 into 6 into 10 into 12. Now you can calculate this. This becomes 11,520. Half of which is our answer 5760. Is that fine? Oh, 10 equals 5 into 2. So phi is 4 into 1. Like 1 less than each of these. Is that fine, Abhinav? Okay. Do you all understand this problem? Is it fine? You can respond if it's fine. Just give a thumbs up. Did no one understand this? Uh, could you explain? Could you tell me what's the issue? Okay. See, B is 87. I'll remove all this. B is 87, which is 3 into 29. So 5 is 2 into 28 by a formula, which is 56. Half of 58 is 28. So our answer is 28. Okay? Is that okay? Alright, great. So now these two problems are for you to practice. I'll not be covering them right now, but these are for you to practice on your own. Thanks for attending the session. This is the Discord username, and you can tag me this way on the server. Also, the feedback form is linked. The PDF is on the notes and resources. Please give feedback there. Now I'm here for about 20 minutes. You can ask whatever questions and stuff you did not understand. I'll try to explain it better. Or you can ask general NT doubts and stuff, and I'll try to explain it to the best of my ability. Uh, if there have been any questions during the session, can you just all right. Uh, Let me know if any. Yeah, if there's anything you want to ask, please go ahead. I'm in 12. I'll just open a blank side. If you For you to ask me whatever, and I'll try to explain. No doubts. I think there were quite a few doubts during the session, which I said I'll explain later. You can ask them now. Okay, I'll actually open the. Yeah, so for you to see if anything else you want to ask. Okay, okay. Actually, I can do that. I'll discuss this problem once. I'll discuss this problem, and the rest is fine. The rest I'll discuss tomorrow on the Discord server itself, because some people haven't tried them yet, so I don't want to put it in the session. Okay, so we are playing a game. The backstory is irrelevant, but it's fun. So the game is that you write 5 numbers on a blackboard. So 3, 4, 5, 6, 7, for example. Now I remove one of these by my choice. Say I remove 6, 7. With these sum remaining, I tell you the sum. I tell you the sum is 19. Figure out what number I removed. I am telling that I wrote 5 numbers which are consecutive and I deleted one. Now figure out which is the number I removed, because if the sum of the others is 90. So how do we do this? So the numbers I assume the numbers I wrote were n. Okay, I'll check once. Let me just explain this first. See, assume that the numbers are n plus 1, n plus 2, and n plus n plus 4. Now, if I remove any of these, the sum of the remaining will be like 4n plus 6 if I remove n plus 4. If I remove n plus 3, then it would be 4n plus 9. Sorry, 7. If I remove n plus 2, it would be 4n plus 8. If I remove n plus 1, the sum will be 4n plus 9. And if I remove n, then it would be 4n plus 10. See, 4n plus 9, 4n plus 8, and 4n plus 7 can only come from a unique n, because these numbers are all uniquely occurring modulo 4. See, 4n plus 6, 4n plus 8, 4n plus 10 is a repetition mod 4. So 4n plus 6 could have easily been 4 into n plus 1. Sorry, 4n plus 10 could have been 4 into n plus 1 plus 6. Right? Because this number can also exist and this number can also exist. So I want to be able to figure out what n is, right? But if it's 4n plus 7, 4n plus 8, and 4n plus 9. If it's 4n plus 7, I can say it was n plus 3. If it's 4n plus 8, I can say it was n plus 2. And if it's 4n plus 1, I can say it's n plus 1. Right? So this is what you basically do. So if you say 23 is the number, it's of the form 4n plus 7. It's 2 into 8. Sorry, 4 in, uh, sorry, yeah, 4 into 4 plus 7. So you get that n is 4. So the number you must have removed was n plus 3. So your answer is 7. This is 4 into 23 plus 8. So the number you must have removed was n plus 2. And n is 23. So your number is 25. Here, 57321. The number you removed, what is it? Can anyone tell me now? I think you have enough of a clue. Just try, please. Okay. So, see, this is a 4n plus 9 now, because it can be written as 14328 into 4 plus 9. So n is 14328, and the number you removed was n plus 1. So your answer is 14329. Okay? Is this fine? Yeah, great. Abhinav actually posted the answers. Sorry, I didn't notice. Alright. If it's fine, you can put uh, thumbs up if it's fine. And I'll check the YouTube chat once if there are any issues. Okay, so someone posted a property in the YouTube chat that I'll show once. Let's go to the last slide. Okay, so someone says this property GCD. Okay, I'll not use GCD because it's tiring. I'll just okay. So if I'm writing this way, A comma B, that means the GCD of A comma B, and if I'm writing this way, that's the LCM. Okay. So someone claims that is equal to. So okay. Oh, sorry. Eraser. My bad. This is D comma C, and this is what's written. Okay. Okay, this is what's written by someone in the chat of YouTube. Alright. So, oh, Abhinav, what's the issue? While Abhinav figures that out, okay. Uh, Abhinav, the number is 574321. Okay. If the okay, let's see. Like the numbers are 14328, 14329. Yeah, our number here is 57321. 14330, 14331, and 14332. You can easily check that these sum, if I remove 14329, these sum to 57321. Just put it in the calculator. I don't have one right here, but you can check it easily uh, by just this into 4 plus 2 plus 3 plus 4, that's plus 9, which is what we did earlier as well. Okay, uh, right, back to the property. Someone said this. Sorry, this is code packet, and this is code. Okay, so how do we prove this? We'll try it for every prime. So if say A is P1 to the alpha, P to the beta, and P to the gamma, then the left is min of max alpha beta, comma, max of alpha gamma. This is what we want to show is equal to max of alpha comma min of beta gamma. Alright. For now, we'll consider what orderings there could be. Say if alpha is greater than equal to beta is greater than equal to gamma. So from here we'll get alpha. Here also we'll get alpha. Here we'll get beta, and max above this is also alpha. So that's true. Now if beta greater than alpha, greater than gamma, then this will give us beta, this will give us alpha, and this will then give us alpha. Here we'll have alpha, and here we'll have gamma, so we'll again get alpha. Now if alpha is minimum, alpha less than beta less than gamma. So here we'll get gamma, here we'll get beta, and now we'll get gamma. Here we'll get gamma, and here we'll have alpha, so we'll get gamma. So again, all three cases is true, so it's true in general. Alright, that's all there is to this. Okay, so any other issues? Yeah, I think we are comfortably going to end. I don't think anyone seems to have any other issues. Same as problem 6 of end. Oh, no. Yeah. The all the problems I gave were the same problems, but in the NT1 test there was a typo. It was supposed to be 57321, but by mistake it was written as 574321. Yes, so that was a mistake on my side, and that's why the answer was 514329. In the question there was a typo from my side. I fixed that in the PDF I shared on the Discord, and I also updated in the Discord while the test was going on. Okay. So if there are no other issues, alright, I think we can end if there are no other issues. If it's fine with everyone, just put a thumbs up. That's fine. Don't worry about the score. Uh, as long as you understand what's there, it's fine. The score is irrelevant. Alright, I think everyone's fine with it, so we'll end. Uh, Thanks everyone for attending. I hope you enjoyed and learned something. Please fill the feedback form, and you can contact me. This is my Discord username, and you can just tag me as well. You're welcome, Abhinav. Thanks for this. Uh, I hope you enjoyed. Bye, everyone.